So welcome everybody to this public key infrastructure interoperability event. My name is Lonneke Driessen and I'm standing here in sunny Arnhem in the Netherlands at one of the three locations that will be presenting you today with the interoperability demonstration of a certificate trust list. There is a session this morning, there's also one in this afternoon, and the agendas are similar or the same. As Martijn already mentioned, after a short introduction from our side, we will directly move on with the live demonstration, where we will demonstrate what we have built to you, followed by a roundtable discussion of the participants in this demonstration to discuss their findings, their learnings, and their vision for the future. After that, there is, of course, ample opportunity for you to ask questions. And of course, we'll do our best to answer all the questions that you may have. And then we'll move on to a wrap up and conclusion and close this session. But before we dive into this demonstration, I would like to take you briefly through the previous demonstrations we've had so far. This is the first demonstration actually in a row. Over the past 2 years, we have been exploring public key infrastructures for ISO 15118 in several ways. Starting back in 2018 during a global EV charging test event, which ELAT was fortunate enough to host also here in Arnhem. And that is the first time, at least for ELAT, where we demonstrated a plug and charge system and certificate installation using ISO 15118 in combination with OCPP 2.0. And when we learned how one public key infrastructure system could work, we asked ourselves, what would it take to make several public key infrastructures interoperable? In the Netherlands, for more than 6 years now, we are used to and very happy with a fully interoperable ecosystem. Whichever car you drive, whatever charging station you visit, whomever might be your mobility service provider, in the Netherlands, it all works. So this is what we are accustomed to. So we were wondering, how would this work in a setup with a public key infrastructure? So to discuss this with all of you, we organized a roundtable event in September of 2019 in Amsterdam in the football stadium. And we exchanged thoughts with you how this would work. And that resulted into our first demonstration, the public key infrastructure interoperability demonstration using cross-certification as an interoperability mechanism. And we actually build it because that is, for a large part, the way ELAT learns. We build it, we test it, and then we learn more. And also during that presentation, and perhaps you have attended that presentation. If you have not attended that webinar last year, or if you've forgotten all about it, you can revisit that on our YouTube channel. During that presentation, we already discussed with you that there is another mechanism to achieve public key infrastructure interoperability, and that is a trust list mechanism. And that is the purpose of us today. Today we are demonstrating to you how we've made a trust list mechanism work. And again, as with the previous option, we've built it and we've learned a lot. And we are very pleased that we can share that with you today. So having explained what we've done, we think it's important before we move forward to share with you why. So why are we doing this? What is the reason behind this public key infrastructure interoperability effort? And for that purpose, we've made an animation which explains to you in a few minutes the reason why. Martijn.
Do you know what your electric car's capable of? Sure, it's the #1 solution for zero-emission mobility, but it can do so much more. Today, more companies than ever are working on new services that can turn your car into a flexible power unit to balance the electric grid, a power source for your house or your neighborhood, or a smart negotiator that can buy and sell energy from its own battery. All this is possible because of shared protocols, open standards, and dedication. In this way, we keep our market fair and open to new ideas and ambitious startups. But above all, EV drivers can enjoy freedom of choice. Charge wherever you like, whatever you're driving. For these services to communicate with each other, a new universal standard for charging called ISO 15118 has arrived. It's a great start. But in an ever-growing landscape of services, ISO 15118 alone doesn't quite cut it. We need their communication to be private, secure, and widely accepted. To make this possible, we need to agree on a public key infrastructure, or PKI ecosystem. In that way, different market players can distribute any service from any provider through any charge point to any car. In a PKI, every part of the charging game has a defined role. Together they create, manage, distribute, and store certificates, and use these to start and end services. To do this in harmony, secure digital certificates, identify users, and give them access to the services they want. For example, charging without a card, smart charging, vehicle to grid. Who knows what the future will be when we have an open PKI up and running. In the end, it won't matter what car you drive, what service provider you use, or what charging station you're connected to. You and your car will be able to access all available services, anywhere, anytime. Sounds great, doesn't it? Join in and take charge.
So that was the animation of the reason why we think it's so important to work on this topic of an open PKI. There are various ways to set up an interoperable public key infrastructure. And here there are four pictures of all the options that are feasible. So to the top left, you see one single public key infrastructure. So if we were to ask all the industry, the entire industry, so all CSOs, all mobility operators, all OEMs to join this one public key infrastructure, of course, it will be interoperable. This solution sort of reminds me of the famous quote by Henry Ford, more than 100 years ago, who said of the Model T, famous quote of his, he said, a customer can have a Model T in any color he likes, as long as it's black. So basically with this interoperability solution, we would say to the industry, you can choose any PKI you'd like, as long as it's this one. The top right option is cross recognition, which basically means that everybody will join all the different PKI systems. And of course, this would work, but it's not very efficient. So that's why we've moved forward exploring the cross certification option and of course the purpose of today, the certificate trust list option. So this is what we will demonstrate to you, this method of public key infrastructure interoperability. As Martijn also explained, we have 3 demonstration sites. We have one in the Netherlands, in Arnhem, which is here. But we also have one site, whom you'll see in a few minutes, in France, in Versailles. And we have a 3rd demonstration in Germany, in Berlin. Combined together, all these different companies that you see here have worked tirelessly to make this demonstration for you a possibility. And they cover all the parts in the ecosystem, R&D, a trust list manager. And after this session, you will know all about what a trust list manager is and does. Of course, CSOs, EMSPs, vehicles, of course, and a central hub to facilitate all the information exchange, and of course, charging stations. So first of all, before we go to France and Germany, very briefly, an introduction of which of these partners are participating today in the setup in the Netherlands, in Arnhem. For an electric vehicle, we have a vehicle from Stellantis, which you will see in a minute. We have a lovely, beautiful white Citroën DS3. We have a charging station, which is a combination of collaboration between Trialog and Elatenel. Our charging system operation is being done by Drive from Israel. The central hub functionality is provided by eClearing.net, a roaming platform combined by SmartLab and Elatenel. And the mobility service provider role is at this demo setup Shell New Motion. So these are the participants who will demonstrating to you today from the Netherlands. And now I'd like to hand over to France, to Vedicom, to Joe Mata. Joe, over to you.
Yeah. Hi, hello, hi everyone. Thank you, Lonneke. I'll let Rock, Director of the eMobility Department in Vedicom, do the introduction. Thank you.
Thank you, Joe. Thank you, Lonneke. Welcome everybody to this second demo site. So we are coming to you from Versailles, near Paris. So this is the second location where we will be conducting the tests. So a couple of words about Vedicom. So yeah, today we are very glad and happy to be one of the hosts of this event. And for those of you who don't know Vedicom, we are an institute and a research institute that operate R&D in a private-public partnership fashion. And we are focused on new mobilities, especially electrification and electric vehicles. So from our DNA, we are at the interface between the electric vehicle and the infrastructure. And our mission is to accompany and help our industrial partners and public authorities in achieving a successful and harmonized deployment of the next generation e-mobility technologies for France and the European market. So at Vedicom, we've been conducting R&D work efforts on the ISO 15118 protocol since 2014 and 15. And in 2019, as Lonneke said, we joined the effort on the plug and charge, and we had a focus on this topic. And as said, today's demonstration will be focused on showcasing the certificate trust list as a technical solution to operate the multiple V2G route for PKI interoperability for the plug and charge and smart charging. So as you will see throughout this day, this event is a convergence of a collaborative effort of industry leading actors and institutions that we were able also from our side to co-organize with our Mobena initiative partners that we thank also. So the objective, as we said, is to showcase in a real life scenario the certificate trust list as an interoperability mechanism. And yeah, we are here with the Vedicom team that I thank very much for all the organizational efforts, and our partners that have contributed to preparing the demonstration and that will be operating with us the demonstration at Vedicom. So Thales for the cybersecurity, Freshmile and SAP Labs, and Girev, Thomas Fuss from Girev, that Thomas. Yes, so Thomas will be taking us through the different steps of the demonstration today. And of course, Aguerre and Trialog that have provided us with the charging stations that you can see here beside the Vedicom one. We are also, of course, joined by our OEM partners, so Stellantis that provided a car in the Netherlands, and behind me you can see this beautiful blue Renault Zoe that will be providing us with a way to test our demonstration. And before starting, I would like to give the floor to François Collet, who is the representative of Renault, and who will share with you some of the motivations of the OEMs in rolling out this plug and charge features and their motivations for this demonstration. François.
So, good morning to everyone. Thank you, Rock, for the invitation, and I'm very pleased to be part of this event. For Renault, from the beginning, the EV and PHEV charging was seen as a service, and a lot of actors plays a role in this service, and each of them could put for sure constraints, but may also offer opportunities. Therefore, some compromise should be done, and a communication protocol was needed. ISO 15118 was one proposal. Renault has always been part of the ecosystem, firstly by being part of the standardization of ISO 15118, secondly by being part of all the discussion regarding smart charging, especially at European level, and Renault support even focusing on interoperability and also exchange of experience, because it's always very interesting to exchange our own experience, what is working, not working, and why. And Renault has always been part of such demonstration. And we believe that now we need to speed up the demonstration and deployment of ISO 15118. And finally, Renault support and will always support VDECOM in both ways, so interoperability demonstration and deployment of 15118. Thank you very much, and I wish everyone a pleasant event for today.
Thank you, François. As we said, so we have three demonstration sites, and from the team here at Versailles near Paris, I would like to give the hand to our third demonstration site in Germany, and wish all the attendees and participants excellent demonstration half day, I would say, and we'll get back to you very soon. Thank you.
Let's see, Stefan, are you ready?
Morning, everyone.
Good morning. Can you share?
Good morning, everyone. Hey, good morning. This is Christian, and welcome to Berlin. We are very happy and very proud to also be able to participate in this testing day today. As you may know, Hubject already has invested a lot of time and resources since 2014 into the topic of ISO 15118, because we believe that the future of EV charging needs to be a very interoperable and a very collaborative future. And therefore, we are really happy to participate today, because we also believe that the future of EV charging, as mentioned, will be highly connected, but also we see that there are good reasons in the market why companies are choosing to work with different PKIs. We also appreciate that, of course, that security is becoming a more and more relevant topic for the future of EV charging. And therefore, again, I'm very happy, together with my team, who have prepared this wonderful testing day today, to participate, to explore new possibilities, how we jointly, as the European EV market, can foster the development of new services and new standards and new protocols, because we also believe that this is still a very early phase of the market. We all believe that, of course, we are just starting the ramp up to a mass market, and therefore I think also it's our responsibility as companies active in the EV market to help creating this ramp up in the market, to help solving technical issues, maybe even business issues, so that also a lot of additional companies can, as easily as possible, enter the EV market and participate in this development. So therefore, we are very happy and proud to participate in this workshop today, together with our partners. Some of them you can see in the background. We have prepared testing cases, which we are where we are really already excited to test them with our partners in France and in the Netherlands. And we hope that the results we are able to create today will also have a positive impact, a positive stimulation to other companies following our activities, also adopting services like plug and charge, where is it as easy as possible that EV drivers can just plug in to every charging station around them, so that they can really experience seamless EV charging, which we believe as Hubject is definitely one of the key criteria to enable a more more successful EV market. In the end, we also want to find solutions how we can also take into account that maybe the market is working in different velocities. You can see it a bit in our background. So we have tried to make this able by combining things from the past with things from the future. So as you can see, we have electrified quite famous car from the past, a so-called Trabant, which is participating today in this testing day as an electrified version, because we also believe, as mentioned, that our responsibility as the industry is to find solutions not only for the future, but also helping stakeholders, helping companies to join this future based on our efforts. So therefore, thank you again, being able to participate today as subject. Thanks to our partners which are supporting us here today, but also thanks to our partners in the Netherlands and in France to make this happen. Thank you very much.
Okay, thank you very much. So then it's now time for the actual demo in a few minutes. So today you've seen we have several locations. We have France, we have Germany, we have the Netherlands. You've already seen a lot of logos and a lot of people, a lot of companies passing by. But the focus for today is, of course, PKI interoperability. So to simplify for the audience to follow what's happening today, we will try to simplify everything to use just the colors of the PKIs within the presentation. So during the presentation, use multiple scenarios we will be playing, and we will be using these circles with these colors, right? So the ELAT PKI will be a white circle, the Vidicom PKI will be represented by a blue circle, and the Object PKI with a black one. And throughout the demo, you see a number of scenarios, PKI interoperability scenarios that will be represented by these type of schemas, which will be shown during the demonstrations. And the idea for today, as mentioned, is to use the mechanism of a certificate trust list. Now, I think the first step is, of course, to understand what it is. So how does a certificate trust list work? What is it? What are the features of it? So, and for that, we have Thales, who will give now a short introduction to the certificate trust list. So I'd like to give the microphone to Pierre, who will give an introduction.
Thank you, Paul. Hello. I hope you will be able to see my screen. Sorry for the the camera. Can you see my screen correctly?
We don't see it in presentation mode yet, so we see the background.
Okay, now it should be okay.
Yes, here we are.
Okay, sorry. So I'm going to present you a little bit the concept of certificate trust list for V2 Grid. So the problem we want to solve, as explained, is that we want to deploy more than one PKI for V2 Grid. So we will have more than one root certificate authority, and so more than one root CA certificate. Okay, and not only we want multiple PKI, but we want also to have a dynamic ecosystem, meaning that a PKI can run out of business suddenly, or you can have a new actor that want to create its own business. So we want to have people in and out very quickly. Okay. And at the end, what we want is to obtain a mutual trust between any pair of certificate holder, between any type of car and any type of charging station or any other actors. Okay. And to do that, Lonneke has started to explain that we have classical solutions that are well known in PKI technology. So the first one is trust store, or also called cross recognition. Okay, where you just have the list of the root certificate that you trust in any station. This is very simple. This is what you have today in your browser, for example, in your PC. However, it's simple and flexible, but it's not that secure because this list of certificate is not signed, so you do not have any real integrity. You don't know really if you want to add a certificate, if you really trust the PKI for which you want to add the certificate. And all actors, they need to question themselves, is this PKI trustable, maybe perform no audit on it, and so on and so forth. So it's really a lot of duplicated effort. Second type is cross-certification, okay, which solve the problem of security. Okay, and it's also simple because you just embed one trust anchor, which is your own root CA. So it's also quite interesting. However, you still have to build trust with the other PKI. So you still have to perform those audits, for example, and it's also still duplicated effort. And of course, it's quite good if you have a small number of actors, but if the number of actors is growing, then you have, of course, if you have n actors, you have n to the square links. So the complexity is growing quite rapidly. To avoid that complexity, you can nominate one actor as what is called a bridge CA, which is a central PKI that will cross-certify the other PKI. So you solve this this complexity, but the remaining problem is that you have a lack of flexibility, meaning if you want to remove one PKI, you will have to perform a revocation of its certificate. So this is not really simple. Okay. And the solution we have chosen today, it's the certificate trust list. Okay. So it's a list of the root certificate that are trusted by the system and which is signed by an actor, which is called a trust list manager. And if you send to everybody this list, signing list, along with the certificate of the trust list manager, you will have a system that is flexible, secure, that is also that will delegate to one actor, which is the TLM, the role to check all the PKI, so you do not duplicate the effort. And you can remove at any time any actor. So it's kind of a good trade-off that we have chosen. To explain you a little bit more how this TLM is working, okay? If you have a new PKI, for example, this one that want to enter into the system, the PKI will send its root certificate to the TLM operator. Okay, that could be, I don't know, industry association, or in Europe could be the European Commission. So anybody that is trusted to operate the TLM system. There will be an entry point where you can candidate for being recognized PKI. So you will send your certificate, but also all the documentation concerning your PKI, like your CP, your CPS, documentation about your company, and so on. And then there will be someone that will check that you are trusted and that you comply to the policy and the rules agreed by everybody for acceptance into the CTL. So if it's okay, there will be a manual transfer of your root CA into a server, which is the implementation of the TLM. So the TLM, obviously, for security reason, is not connected to any kind of network, so it's a manual transfer. And then the root CA certificate will be entered into the database of the TLM, and the new certificate trust list with this certificate added will be signed with a private key, which is stored into a HSM, hardware security module, for security purpose. And then you will have your new certificate trust list, okay, with all the certificate and which is signed. So then this certificate trust list will be transferred back to a public location, which is connected to the internet, like a website, and it will be available to be published and to be retrieved by all the actors. For example, here, all the cars and all the charging stations. All those actors will have the TLM certificate, okay? That will be needed to check the signature of the CTL, okay? And if the signature is correct, of course, the date of issuance will be also checked, and a few other details. If everything is correct, then this CTL will be accepted by all the actors, and all the certificate, the root CA certificate containing it, will be subsequently accepted for the transactions. To bootstrap this TLM system, in fact, the only requirement that you have is that you need to manufacture each station, each object with the current TLM certificate and the URL of what is called the distribution center of the CTL. If you just have that, then you can retrieve the CTL and you retrieve the latest full CTL, and then you check the security as explained before, and you add all the root CA certificate into your trust store. You can also update the TLM certificate and update the URL of the distribution center to have a fully dynamic system. Finally, what I want to mention that this certificate trust list manager concept is not something that exotic, because it's currently deployed for two use cases. Okay, so the first use case is vehicle to vehicle and vehicle to infrastructure communication in Europe. So it's also in the car industry. So it's the deployment of this communication between vehicle and for example, traffic light is just starting. I think that last year Volkswagen has already put on the road some cars implementing this kind of communication. Of course, it's signed. The message are signed, so you need a PKI, exactly like we have into the vehicle to grid communication. And there is a TLM. Okay, this TLM is operated by a neutral actor, which is the European Commission. Okay. There is a standard governing, for example, the CTL format, which is done by ETSI. So it's fully interoperable. And the CTL is downloaded by all the cars and the infrastructure, which is very, very similar to our use case of EV charging. And just to give you an idea, there are 22 root CA certificates in CTL, so you can go, I mean, already it's already a lot of factors in this CTL, and it's working well. Another example, which is purely national in France, is the 2D doc signature for administrative document. So it's deployed by administration and also utilities like MNOs to put an electronic signature on paper documents or documents that you can show on your mobile phone. So for example, here you have an invoice from SFR, which is a MNO in France, and you have this document signed by an electronic signature, which is encoded into this 2D barcode. And if you produce this document to justify your postal address, for example, you can decode the barcode, check the signature, of course. But in France, we wanted to have open market and so have multiple PKI. For example, SFR can choose one PKI and Bouygues Telecom can choose another PKI. So there is a need for a certificate trust list. And this certificate trust list is operated by NTS, which is the agency in France who is issuing the passports, and it's a national agency issuing the passports and driving license and so on. As it's a smaller market, we just have 4 root CA in CTL, which is already a lot for France. And it's fully deployed and operated right now. Just for the anecdote, I have put here the 2D barcode that I can show on mobile phone, showing that I have received the first dose of vaccine against COVID. And it could be checked by any barcode reader on my mobile phone. If I want to, I don't know, maybe it will be the basic for these health passports that we are talking about for European Union. Okay, that's it for today. So just for you to remember, the CTL certificate trust list and trust list manager, they are already deployed and standardized. We think that it's a good approach for multi-routed PKI in V2G because it's flexible, open and secure, and we have just one governance and policy which is managed centrally. Thanks for your attention. And back to you, Paul.
Okay, one moment. Let's see. I think we are going to Vedicom. Are you ready? I can't hear you yet. Joe, can you say something? I can't hear you yet.
Hi, do you hear me now?
Ah, yes, we have audio. Okay.
So, hi everyone, I'm Thomas Fuss from Genève, and I will present the first scenario of this demonstration. In this scenario, all actors are under the same PKI, the VDCOM PKI. So we have an electric vehicle owned by a user. This user will take a subscription to an EMSP. We have a charging station managed by a charging station operator. And we have a central hub, which takes the role of certificate provisioning service and of contract certificate pool. The first step is for the user of the vehicle to take a subscription to an EMSP. So we will just switch to the interface of our EMSP, FreshMile. So as you can see, it's a basic interface where the user of the vehicle has just to put its vehicle ID and click on submit to ask to FreshMile to generate the contract certificate and so on to enable the plug and charge for his car. So what happened after? So we have the EMSP. The EMSP has the provisioning certificate ID and must generate the contract certificate for the vehicle. This contract certificate will be packaged in a contract certificate bundle. This bundle includes the private key of the contract certificates. But this private key is encrypted to be and can be decrypted only by the electric vehicle. Then this bundle will be signed by a certificate provisioning service, and this signature will ensure the vehicle that this contract certificate bundle has not been corrupted between its generation and the moment it is installed in the car. Finally, this signed bundle will be stored in the contract certificate pool. Now, the user will plug his car for the first time to a charging station. What happened? We have a 1511.8 electric vehicle and a 1511.8 charging station. So they will initialize a 1511.8 communication. The first step of this 1511.8 communication is the TLS handshake. And during this handshake, the charging station will present to the electric vehicle the certificate, its certificate. And as all actors are under the same PKI, the VDCOM PKI, the electric vehicle trusts the certificate of the charging station. After, the electric vehicle requests the charging station to get its contract certificate. So the request goes to the charging station, the charging station operator, and to the contract certificate pool, which return the signed bundle, including the contract certificate. And again, as the signature of the signed bundle has been done by an actor under the VDCOM PKI, the electric vehicle will trust this bundle and install the contract certificates. Finally, the electric vehicle requests the charging station for the authorization of the charge, passing the contract certificate. And again, as this contract certificate has been generated by an actor under the VDCOM PKI, the charging station trusts this contract certificate, and the charge has begun, as you can see behind me. So this is the first scenario, the more simple. Everybody is under the same PKI and everything works well. So now I let my colleague from ELAD to do the second scenario. Thank you.
Thank you very much for this first demonstration. So the next scenario will be an interoperability scenario. And as mentioned, we will be using a certificate trust list for that. Now, in the beginning of this webinar, Pierre from Thales explained the concept of a certificate trust list. And before we go to the actual demo, I'll first go into what this means for the ISO 15078. So for the interoperability for an ISO 15078 ecosystem, you actually need three different parts of the setup, where there is interoperability involved when it comes to charging a car. First was the TLS handshake, as just mentioned. There's the certificate update and installation, and there's the plug and charge identification, where you actually plug in and start charging. For the TLS handshake and for the certificate update and installation, basically what you need there is interoperability between PKIs using the V2G root certificates. So there we will be applying a CTL for the V2G root CAs. For plug and charge identification, you can use either V2G roots or MO roots. So there you could also have a certificate trust list for MO roots CAs. So in the demonstration, we will show different scenarios with different components from different PKIs. And we will also show several variants. Just to explain a bit more in detail, so the first variant for the TLS handshake, if you, for example, have a car from a root CA B, in this case, a yellow one, that wants to charge at a charging station that is from a different PKI, in this case, root CA A, then there will not be it will not be possible to do this handshake because the root CA B is not able to verify the chain that it receives from the charging station. Now, what we will be applying in this demonstration is that we will have a certificate trust list containing multiple root CAs, and this will be transported in some way to the car. Once the car has received this root CAs, then it will be able to verify, in this case, root CA A, that this chain is valid, and it will be able to connect to the charger. Now, this is actually the next demonstration scenario. So the demonstration scenario we will show in a minute looks like this. So we have a vehicle, the nice Citroën DS3, as Lonneke mentioned, from the Vidicom PKI that will be trying to charge at a charging station, CSO, Central Hub, and EMSP from the ELAT PKI. And as you will expect, of course, this will not work. So let's go to the demonstration and switch to the camera, and then we will first do this scenario where it doesn't work. There you go. So the first step is, of course, to plug in the car. And as you can see, the light goes off and nothing happens. So the car is not able to charge because it cannot perform the initial step to establish a trust relation between the car and the charging station.
So it's okay?
Yes.
So, hello everyone. In our demonstration, our EV is connected to Stellantis cloud through an embedded connector box. And from the interface of this cloud, you can find that from the left side of the screen, we can send the update of the trust list request to the EV. And you can say from the right side of the screen, the communication data is ongoing, and this process will last for several minutes, and we will go back to this demonstration after everything is done.
Okay. Thank you very much. So as we've just seen, okay, thank you very much. So as you've just seen, this was the scenario where the car was not able to connect. And the step that Juan just explained is that he will be sending a certificate trust list to the vehicle. So it's actually doing the process of sending the certificate trust list to the car, to send the certificates to the car and to install them. Now, in this demonstration, it will take some time. So this is in real life, this will not be a step where the user is actually waiting for it. This is typically something that is done in the background. You can probably imagine the telematics connection between an OEM and the car is, of course, not only available when the user is charging, but it's always online. And of course, these type of updates will normally be done over the air, for example, during the night. So normally a user will not notice that this will be happening, but for the demo scenario, we of course introduce it to demonstrate. So we just have to wait a few seconds for a few minutes actually for it to take effect. But as mentioned, this is like a demonstration to show this, and this will not be realistic for real life scenarios. So we will wait a few minutes. I'm looking at my colleague, just 1 second. And while we're waiting, maybe just to repeat my colleague Martijn, if you have any questions about the demonstration or later in the presentation about the round robin discussion, the roundtable discussion, feel free to drop a question in the question box, and then we can either answer them directly or we can use this in the panel discussion or afterwards in the Q&A session. Yes, I see that the setup is ready again. So we'll switch back to the camera again, and then we can see the next step of the process.
So let's back to our demonstration. One moment. Yep. Let's back to our demonstration, and you can find here this ALAD V2G root has successfully installed to the EV, and we can just try again to plug in. And you can see the communication is ongoing. We have successfully installed the contract. And in a few seconds later, the charge will start. The charging start. So you can find from our cloud interface this contract from ALAD is installed.
Thank you very much. I'm switching back to the slide. So now we have a car that trusts both the ELAD as well as the Vidicom PKI, and we can see that an actual charging session was possible. Now, as an intermezzo, we will have a short view at the certificate trusted variants that we have looked into in our project. So we have investigated how to use the certificate trust list and how to get it to the car. And we have looked at several variants, actually 3. The first one is the one that you have just seen. That was that CTL was sent via the OEM backend to the car as individual certificates. And the alternative option would be to send the entire list. And then the third option would be to send it via the infrastructure. A little bit in more schematic overview and more detail. The option we just saw was the CTL being sent to the OEM backend. The OEM backend was actually unpacking the CTL and verifying it. So verifying that the signature is valid, and then sending the individual certificates to the car to make sure that the car can charge. The second variant, where it would also be possible, then the certificate trust list would be sent in its entirety to the car. This puts the burden of verifying the certificate trust list and unpacking it on the EV side, which of course can be done, but would be an additional burden on the EV side. And the third option would be comparable with the certificate installation, the contract certificate installation, and to do it via the infrastructure. So that would mean that the CSO would have to get the certificate trust list and install it in the charging station, and the EV should be able to fetch it. So those are the 3 variants that we will have looked into. And the third variant is actually the setup that we'll be demonstrating now. The next setup looks like this. So the scenario is a bit different. Now we have an EV emulator. that is together with the charging station and the charging station operator from the ELA PKI, and it's connected to the central hub and, of Vidicom, where a contract is prepared by an EMSP from the Vidicom PKI. And well, as expected, this will this should fill. So let's go to the camera again and look at this fill scenario. Yes. So my colleague is now plugging in the car, or actually the car emulator, and we can see on the screen now that it has already stopped. So you can see that it tried to connect, but it immediately failed. And the next step is to install the certificate trust list in the car. So my colleague will do that now. For demonstration purposes, we made this feature made it possible to enable and disable this feature on the EV emulator side. So now he has enabled this functionality, and now we are fetching the certificate trust list from the charging station by the EV. For this, we used on the 1511.8 side, we used a value-added service, the extension feature of the ISO 1511.8 standard. And on the charging station operator connection, we are using OCPP 2.0.1. And there we are using the data transfer mechanism to transfer the certificate trust list from the CSO to the charging station. And as you can see, the car can now charge at the station using a contract from the Vidicom PKI. So let's go back to the slides again. So this is the scenario, the demonstration that we have just seen. So during our project, we of course not only implemented and built it, but we also looked at the impact the several variants would have on the existing implementations and standards. Now for the telematics variants, the ISO 1511.8 is not involved, and the same goes for OCPP. So for those variants, there will be no change involved. For the infrastructure variants, as mentioned, we use the value-added service for the 1511.8 connection, and we use the data transfer extension mechanism of OCPP 2.0.1. If this for infrastructure variant would be applied in practice, and these should either be standardized in the market by adding them to the standard or to an interoperability guide. Several interoperability guides are already available, like the VDM and the interoperability guide that's currently being created by Sharon. So this would be sort of the impact if you would introduce a certificate trust list in different variants in the ecosystem. And then, of course, the question is, what's the most feasible variant? What's the most likely one that will happen? Now we've looked into what the impact would be on the different components. And as mentioned, once you put the burden of sending the entire list to the car, then the car should be able to verify and unpack the certificate trust list. So that is a sort of a disadvantage of that approach. And for the infrastructure variant, there's also the so-called chicken and egg problem. There is a workaround for it. The issue there is that if you want to have a secure connection to install a certificate trust list, you should have a secure connection in the first place. So this sort of chicken and egg problem can be circumvented by, for example, introducing a new route on the certificate trust list long before it's operational, so that existing implementations can already fetch the certificate trust list. But these are things that has to be taken into account. But looking at the current state of what's in the market, it's unsure whether OEMs will actually support this feature on the car side. So from our view, it's the most likely conclusion would be that the option that we have just shown with the vehicle, so the telematics option where the individual certificates are forwarded to the car, seems most realistic. So that were two PKIs that were made interoperable using a certificate trust list in two different scenarios. And now we are going to the third PKI. And for that, we switch to Berlin, to Stefan.
Hello, welcome back to Berlin. Yeah, thanks, Paul. Yeah, you just raised it. In our scenario, we as subject, we will join now to this PKI market. So that's the third PKI. And what we want to show you is that, of course, the trivial path, charging station with one PKI is charging with one car with a regarding V2G route is working, and what happens if we plug in this vehicle to another charging station which has a leaf certificate from a different PKI. This is the first thing, and after that we will show how to solve this. So as you see here, this is our station which is connected with a Hubject ecosystem and has a leaf certificate from the Hubject V2G route, which is shown in black. And this vehicle has just installed the black V2G route, so just one. And yeah, of course, this should work. So now we get the TLS handshake, the installation, and soon is the authorization over the backends. And you see the Trabi is charging. So this is, of course, the trivial path, which works, of course. Now the plug needs to be removed, hopefully. The order is important. We can do it like this. This is a demo scenario, so it looks like the simulator doesn't want to remove the plug. Okay, thanks. And what do we want to show now is that this Hager station, which is connected to the Vedicom backend and has a leaf certificate from the Vedicom PKI, it shouldn't work. So now we will plug in and we'll start. Yeah, and now we get a TLS handshake error, so it doesn't work. In short, what we just did is, you see here an EV with just one route, cannot be connected to the blue PKI charging station, and can just charge with one kind of charging stations in the market. After the break, we will show you how to solve this as explained. So I want to summarize for you what we just did with Paul and Joe and so on in the previous slides. So we have 3 PKIs available now in the market in our scenario. 2 are already interoperable to each other, so means they are trusted in the certificate trust list and they can be downloaded in cars and so on. And we showed, I think, in different scenarios what would be the impact, or what is the impact. So I just showed you what if you do not do anything here on the interoperability or the technical possibilities. We introduced the concept of certificate trust list as one opportunity to solve this chicken egg problem, or this problem. Paul also mentioned the impact on existing implementations and standards. Means we shouldn't introduce something which is kind of destroying or sabotaging the current implementations on the market. So they still need to work. We have to add a technical possibility to let them do plug and charge as they are doing it today with us, and also introducing the possibility of interoperability. And of course standards, because how do we get the problem solved that everyone is going with certificate trustless? So it needs to be somehow standardized, and so we get the acceptance in the market. So this is a really important point, which is very, very hard and time consuming. We have and then the other thing is the feasibility of the variants. Means we just showed a lot of variants what could be possible in installation of the V2G routes directly over the trustless in the car, but also in the backends. We can install it over the CPO and the EVSE. So we showed some possibilities, but I think, or we think that we need to agree, or we need to get a common practice out of it. So we need to do some more research to see what would be the most or the least biggest impact on current implementations, on future implementation, to get this working. After the break, we will add the third PKI, the Hubject PKI, the black one, to the certificate trust list, and we will show you in certain scenarios how to enable then the interoperable charging. So I as we talk now already an hour, so we give you the time to have a 15 minutes break and see you back in 50 minutes at 17:15 our time. Enjoy your coffee and talk to you soon.
Okay, hi again. So go back to France for the next scenario. No. Okay. So during the previous scenario, the electric vehicle has been updated with the last version of the CTL, the Certificate Trust List. So now the electric vehicle trusts the PKI from ELAD and the PKI from VDCOM. In this scenario, the user of the vehicle decides to switch his EMSP. So the user closes its contract with the EMSP Freshmile and takes a contract with the EMSP from the object PKI. And to add more complexity, the user decides to use a charging station under the PKI object. So the first time the electric vehicle tries to plug to the charging station from the PKI object, it doesn't work. Why? Because, as I said previously, this is a 15.11.8 electric vehicle, 15.11.8 charging station. When they connect, they try to initialize the 15.11.8 communication, TLS on check. The charging station presents its certificate to the electric vehicle, but the electric vehicle doesn't trust this certificate because it comes from the object PKI, and the electric vehicle only trusts the ELAD and VDCOM PKI. So what do we have to do? As I said, the electric vehicle has been updated with the last version of the CTL. But in this version, the object PKI was not included. So object has to be enrolled in this certificate trust list. So the object PKI has to go to the trust list manager to add its V2G root in the certificate trust list. Now that the trust list contains the object PKI, the electric vehicle can be updated with the last version of the certificate trust list. And as you can see, this flow passes through the OEM backend. So now our electric vehicle trusts the object PKI. And when the user plugs his car, the electric vehicle now trusts the charging station certificates. So the 15.11.8 communication is initialized. The electric vehicle will ask for its contract certificate. So this request goes to the contract certificate pool, which returns the signed bundle containing the contract certificates. The electric vehicle trusts this signed bundle because the signature of this bundle has been done by an actor under the object PKI. So the electric vehicle installs the contract certificates, and the electric vehicle uses this contract certificate to ask for the authorization of the charge to the charging station. And the charge begins. And now for the next scenario, I'll let objects present it. Thank you.
Hello again. So thanks for handing over. So now, as promised, what we did is to add to our vehicle. Jetzt ein bisschen runter die Kamera. To our wiki all routes from the certificate trust list. So means
you're back
sorry,
again.
now it's there. So yeah, now I'm back there. So, sorry. So what we want to show is now that before it didn't work to charge this station, which was connected to the blue PKI, or had a blue PKI leaf certificate with our simulator, which had just the black V2G root from object in there. But what we want to show is that this way works now when if we do something. So we have a small technical issue. I will just press a button. So then the first thing is we need to download the trust list, the certificate trust list, and we need to extract it. So we are kind of simulating the way like Paul described, that the OEM backend is extracting all the roots from this trust list, is trusting it, and we are installing it into the vehicle. As we have a simulator, we are doing it manually. So in this case, we just did it. So all roots are in here, and the charging process with this simulator should be possible now. So now it's start. There's authorization and installation, and now it should authorize. Yep, as you see, the light turned on again, and this is the part we wanted to show you. Also on the left bottom on the screen, you see the 3 installed routes from our simulator. So if you click again, then we should see that the contract certificate got transferred into the vehicle. This was our part in showing how to add the third PKI, or like to add all PKIs into the simulator and to have this vehicle kind of able to do not care about which station it should drive to. It can just go and have an interoperable charging experience. I hope that showed this path. I'm happy to hand over again to you.
Hi again. So for the last scenario of this demonstration, we have still our user with its electric vehicle, trusting the 3 PKIs. And for the last, our user decides to go back to the first charging station from the VDCOM PKI. So when the user plugs its car, when the user plugs its car to the charging station, first time, it doesn't work. Why? Because so as the electric vehicle trusts the VDCOM PKI, the 15.11.8 communication is initialized, and the electric vehicle presents its contract certificate from the black PKI, the object PKI. And now the problem is that the charging station doesn't trust the black PKI, the object PKI. So like the electric vehicle, like for the electric vehicle, the charging station must be updated with the last version of the certificate trust list. So this time, it passed through the charging station operator, and the charging station is updated with the last version. So now our charging station trusts the 3 PKIs. And when the user plugs again, normally everything should work. Why? Because now the charging station trusts the contract certificate from the black PKI. So thank you very much. It was the last scenario of this demonstration, and I let Paul make the conclusion. Thank you.
Yes, thank you very much. So yes, some final notes on what we have seen today. So we've seen a number of demonstrations of the certificate trust list for PKI interoperability. In the start, we Pierre from Thales explained the CTO concept as a method that's applied more often. So it's a common method for PKI interoperability. And during the demo, we hope we have showed you several variants, several scenarios with different components from different PKIs being interoperable when using a certificate trust list. We've done some research during the project, so we were not able to tell you everything, to show you everything. But our conclusion is that it's a scalable way of adding PKIs to the ecosystem, having a main limitation on the amount of memory in the EV, because as you have seen throughout the demonstration, every time the certificate trust list is used, the certificates that are on the list are installed. So especially on the car side, this would be, there's a challenge. But all in all, we think this is a solution for PKI interoperability within an ISO 158 ecosystem, in addition to cross-certification. So we think it's good, it's scalable, especially when more PKIs become operational, as Thales Pierre introduced in one of his examples. He even had 22 VTG routes on the list. Of course, it does mean that the EV must be able to hold these larger numbers. And of course, when all these are then also added to the vehicle trustor or to the charging station trustor, then that means that an EV user can choose the car it wants, the EMSP and the CSO can join the PKI they want, and all the components should be interoperable. So I think that is a nice conclusion to start the roundtable discussion with.